Compromised credentials are the number one cause of a data breach, and Enzoic allows you to continuously and automatically manage this growing area of risk. In this demo, I'm going to walk you through Enzoic's real-time credential protection workflow, showing how the Credentials API and Passwords API work together to detect compromised logins, step up authentication, and enforce secure password resets. And you can try this for yourself as well at demo.enzoic.com/login. And as you can see here on the login screen, we're going to enter our credentials, with the email being test@enzoic.com and password 123 exclamation point. The moment the user hits login, Enzoic's Credentials API is working behind the scenes. It quickly checks this exact username and password pair against Enzoic's database of compromised credentials. In other words, the system is asking, has this specific login combo shown up in any data breach? The lookup happens almost instantly, in just a few milliseconds, and the user doesn't notice anything special happening in the UI. This is a seamless step to catch breached logins without adding any friction for the user if all is well. And in our case, you'll notice we used a fairly weak and likely compromised password for the demo. Sure enough, Enzoic's API finds that these credentials have been exposed in a breach. From a security perspective, this is critical information. It means attackers also know this username and password pair. Rather than letting the login proceed normally, the app intercepts it for safety. This is what prevents a credential stuffing or account takeover attack. Even if a bad actor has stolen credentials, they won't just be able to walk in. Developers implement this by integrating Enzoic's API call into the authentication flow. After the user submits credentials, but before creating a session, the app calls Enzoic. If the API returns a positive match, meaning yes, this login is in our compromised list, it can block the login and initiate a protective action. You might force an immediate password reset or take other corrective steps when this happens. In our demo, instead of logging the user in straight away, you'll see we trigger a different path, a step-up authentication challenge. This is a secondary verification step to make sure the user is actually the account owner, and this extra challenge is completely customizable. In our demo, it's a security question, but it could have just as easily have been a one-time PIN, an email verification link, an app-based MFA push, or any other method to verify identity. The security team might even opt for manual review in certain high-risk cases. The key point is the Credentials API's alert give you the opportunity to raise the assurance level of the login. We only present challenges like this when a user is compromised, which keeps things user-friendly during normal logins, and tougher only when it really needs to be. So for the step-up challenge, I can go ahead and type my favorite color, which for the sake of this demo can be any answer. And now we've arrived at the password reset screen, which you'll notice is automatically prompted after the step-up. At this point, the user has proven their identity, and we're requiring them to set a new password because the old one is unsafe. This is where Enzoic's Passwords API comes into play. As the user types and submits a new password, the application is checking that password against Enzoic's compromised password database in real time. You'll notice if the user tries something like password 1234, just adding a number, for example, the system would likely flag it with a red warning, letting the user know that it has previously been breached. That's because it's still a known compromised password. Instead, we need to choose something that's completely unique. These password change checks can also include any password policies or complexity that you want your users to comply with. Technically, here's what's happening. The app takes the new password the user entered and hashes it for security. Rather than sending the full hash out, and certainly never the plain password, it sends just the first 10 characters of the hash to Enzoic's Passwords API. Enzoic's server then looks up any password in our database that has a match with the prefix and returns a list of candidate hashes that could match the user's password. The application then compares the full hash of the user's new password to those candidates locally. If it finds a match that tells us the exact password is known to be compromised, it's essentially on a deny list of hacked passwords. In that case, the app will reject it, prompting the user that they can't use that password and need to choose something safer. If none of the returned candidates match, or if Enzoic returns a 404 not found for that prefix, it means the password is not in Enzoic's breach database, and thus is not a known compromised password. Only then will the new password be accepted. This ensures the user cannot choose an unsafe password as their new credential. And before we wrap up here, it's worth noting that Enzoic gives you flexibility in how you use these APIs. In this demo, we use the Credentials API at login and the Passwords API during the reset. However, some organizations might choose to use the Passwords API proactively during the login as well, essentially to check just the password against breach data, even if the full username and password pair wasn't explicitly found. The good news is that Enzoic's APIs are flexible, customizable, and can be tailored to your authentication workflow.